This is a brief look at SOLIDWORKS motion as it applies to a really simple kinematics problem. And so what I've got here in SOLIDWORKS is I've got an open assembly file. I put it in MKS, which is a little unusual. Usually we're in MMGS, right, or IPS, but MKS might work well for our analysis. And I'm just going to insert this ball I created, and I'm going to fix it at the origin. So I click that, there we go, and you'll notice that that's fixed and not floating, right? That's what the F means in front of the word. So when we get into the motion analysis, we'll want to fix that. I also want to check that SOLIDWORKS motion is on. So I go to my add-ins and I check there's SOLIDWORKS motion. It's already on. So I come down to Motion Study 1, and I'm going to go ahead and rename this so I know what I'm doing. This is a falling analysis. And so because motion is on, I can use motion analysis in this motion study. And motion analysis allows me to use motors and gravity and those sorts of things. It's a little bit more involved than just animation. So I've got motion analysis selected. I'm going to go ahead and disable view key creation, and I'm going to set up gravity. So gravity is going to be in the Y direction. If I look at my my directions over here, my axis Y makes the most sense for the way I've set up this experiment. So I'll turn that on. And I forgot to set up a trajectory for this ball. So we're going to go back to the model, and I'm going to put a quick sketch on the front plane, and it's just going to be two lines, a horizontal line and a line up at an angle. And this is your trajectory line. So you can make that any angle you wanted. I'm going to make this 30 degrees. And that's it for that sketch. So I come back into the falling motion analysis, and now I can right-click on my object and give it an initial velocity. And here its direction will be indicated by that line. So I want this to be higher than 0, let's say 7. Okay, now it has an initial velocity. I came in isometric, right? And that's not going to be an easy way to look at the trajectory here. So I'm going to right-click here and replace the key. I just zoomed out a little bit, put it in a front view. And so the last piece I have to do to see any motion is make sure that it's not fixed in place, right? Gravity won't matter if I've fixed it in space. So I right-click on the ball and I click float. And now I'm just going to turn off the origin and turn off sketches. And the very last thing here is aesthetic. Motion study properties gives you the option to change frames per second, among other things. So I'm going to go ahead and set this to 250 frames per second. This won't change the results, but it will change the appearance of the results. So with everything set up, I come here and I click the calculate button, and this ball is launched into space. So let's see where it's going. I'm going to go ahead and stop for a second, because as you can see, I'm losing it on my screen. I'm also going to change how far I calculate here, but let's right-click and replace key and do another calculation. So let's see. It's pretty quickly going to fall off the screen, so I can stop it right there. Probably, 1 second is enough data here, but I'll zoom in and see if I can get just a little bit more. There we go. So I can replay that, but without anything on the screen, it really doesn't give me information about where this ball has come from, right? So last thing we'll do is results and plots. We're going to plot the displacement by tracing the path. And we're going to trace the path of the origin of this ball, and we'll go ahead and play it. And now we can see where the ball starts and where it ends up. And that's a basic kinematic study. In the next one, we'll take a look at some of the other results that you can look at in the next video. Okay, in this video, we'll briefly look at some of the other results you can look at in a motion analysis. Again, this is just a simple kinematics example. So if you are looking to set up a result, again, this is the tool, and you can look at a number of different results. we're looking at kinematics. So we're only considering how it's moving. We're not looking at forces or anything like that yet. So there's a number of different plots I've got set up here, and I'll edit the features so you can see how they're set up. So the first is looking at the position, center of mass position of this object. And I can look at that in both the x and the y directions. All I do is I set up my displacement, velocity, acceleration, center of mass position, x, and then you select the object that you want to look at. We only have one, so that's nice and easy. In order to open a plot that you have closed previously, you just right-click and you click Show Plot. As a side note here, if you've saved this plot over in your right-hand window and you only have one monitor at a particular computer, it isn't going to show up. It's going to project that onto the right screen that doesn't exist. So you do want to try to keep these in your left screen, even though they're in the way. What can we do here? Well, we can change our scale, which is always a good idea because SolidWorks defaults to some odd start and end points here. So I tried to make sure that my start point is less than the smallest value, my end point is greater than the biggest value if it's appropriate, and that my major units are, and minor units are also kind of even numbers so that it's a nice easy graph to look at. So I can see that this goes slightly less than 8 meters, and that's the x direction position, which makes sense because the x direction acceleration is 0, so velocity should be linear, should be constant, and my positions should be linear. So that's plot 2. I can add a title to this plot, and so I'll call this x position, and that shows up here. It doesn't change in my tree here, but it does change on the chart, which is helpful. I can also right-click and export to CSV, and that'll give me a comma-separated values file that I could potentially put in Excel and analyze further. So I'm going to go ahead and close this window and show you some of the others I have. So this is looking at the y component, and we'll show that one. And this one is a nice parabola, which is, again, exactly what I expect. And you can adjust the scale. You can also adjust some other features. Take a look. And we'll give that a quick title. And I'll go ahead and close that window. So now we've got velocity, which is a little bit different. We select linear velocity on this list of options now, and you can do x and y. X velocity you would expect to be constant, which it is. And here, instead of changing the chart title, I changed the axis. If you double-click on the axis, you can choose to use feature name or change the axis text. And then we'll show this last feature, linear velocity y component, and that plot gives me a linear velocity. Positive is upward, so it's getting less and less, or a larger and larger negative number. And here's the, as I said, SolidWorks has some odd numbers here, right? So we'll make the major unit 2, we'll make the minor unit 0.5, I'll have them, this go to -10, and it'll have a top point of 4. Let's click OK. So now those points actually mean something. That is important. So this is just a really quick look at what you can do with a kinematic analysis in SolidWorks Motion. So play around with this, look at some of the features. You can also come back and change the initial velocity. You can play around with gravity. You could change the sketch. That changes the angle of the trajectory, and see how that affects your results. And that concludes this introduction to SolidWorks Motion as it applies to kinematics.